So it's already 20 minutes over, sorry. So I will we know that the Newton's second law of motion, force is the rate of change of momentum. So for non-relativistic case, means suppose if the particle is moving with a velocity which is less than the velocity of light, we know that we can take the mass of the body, the mass of the object is a constant. So from this we can take it outside, that is m into dv by dt, that is momentum is m mass into velocity. So we know that it is mass into acceleration. So this is the Newton's second law and Newton's third law. For every action there is an equal and opposite reaction. So all these things we already know. Now if you come to the impulsive force, what is impulse? Suppose a cricket player, which when he draws his hand back while catching a ball, we are saying it's some kind of impulsive force is there, impulsive force. So what is impulse? So impulse F is equal to, impulse is equal to a large force acting for a short time, that is product of the force and time, the time of interaction, and which is also equal to the change in momentum. So that means we can write F is impulsive force is equal to m into change in momentum. Means if v is the final velocity and u is the initial velocity, then the change in velocity is v minus u. So next we will go for the collision. What is meant by collision? I will quickly I will go through some concepts, and later we will listen. We know that it is a phenomenon where two or more bodies, two or more bodies, there is collision happen. So in physics, it need not be there won't be any physical contact of two objects. It is not necessary. So even if we can say that in nuclear physics, in Rutherford scattering, you might have studied there won't be any physical, even if there is no any physical contact between the objects, we can say that there is collision is happened. So collision means it is the interaction between the two objects which has taken place. And we can classify this collision into two. So one is elastic and inelastic collision. So what is elastic and what is inelastic? So in the first case, that is elastic collision, there is exchange of both linear momentum and mechanical energy. That means both linear momentum and mechanical energy of the system is conserved. Whereas in elastic collision, here only the linear momentum is conserved. And collision, again, we can classify into head-on collision and oblique collision. So what is head-on collision? What is head-on collision? What is head-on collision? So we know that it is head-on collision. There is the relative velocity of the two bodies. Suppose the relative velocity means the velocity before collision and after collision. So if they lie in the same line, or the relative velocity of the two bodies lies along the line joining their interaction or their centers, we can say that head-on collision. And another one is oblique collision. Oblique collision. So here the relative velocity between the two bodies, which does not lie along the line joining of their centers, so which is called oblique collision. And we know that there is law of conservation of linear momentum. In elastic collision, there is both energy and linear momentum are conserved. So what is law of conservation of linear momentum? Law of conservation of linear momentum. So suppose two bodies are moving. Initial velocity, the initial velocity of both bodies are u1 and u2, say. So it is before collision. Then after collision, suppose two bodies are moving with velocity v1 and v2. Then according to the linear conservation of momentum, we can say that the momentum before collision is equal to the momentum after collision. That means suppose this body is A and this body is B, which is moving with a velocity u1, and second body is moving with a velocity u2. Then after the interaction, the first body is moving with velocity v1 and second body is moving with velocity v2. Then according to the linear law of conservation of linear momentum, I can write that m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So from this, the conservation of linear momentum, we can find out the recoil velocity of a gun. You might have studied in your basic classes that the recoil velocity, when you are firing the bullet, when the bullet is going in the forward direction, there will be a movement of the gun towards the backward direction. That is what we are calling it as the recoil velocity. Suppose if small m is the mass of the gun, and capital M is the mass of the, small m is the mass of the bullet and capital M is the mass of the gun, then, and small v is the velocity of the bullet and capital V is the velocity of the gun, recoil velocity of the gun, then I can write the velocity, the momentum before firing. That is, what is the momentum before firing? It is 0. Right? The momentum before firing is 0, and momentum after firing. So momentum, just a minute, there is some problem here. Yeah. So momentum before firing, which is 0, and after firing, which is equal to, suppose capital M is the mass of the gun and small m is the mass of the bullet and capital V is the mass of the velocity, capital V is the velocity, recoil velocity of the gun, and small v is the velocity of the bullet. Then the momentum after firing, it is capital M into V plus small mv. So from this, I can estimate or I can calculate the recoil velocity. So that is V is equal to, it becomes minus m divided by capital M into V. So from the law of conservation of momentum, I can write the recoil velocity. And also we know that if the external force is acting on a system is 0. In the beginning, we have discussed the Newton's second law of motion. So if the external force acting on a system is 0, that means if F is equal to 0, if external force F is equal to 0, then it is dp by dt is equal to 0. That means P is equal to a constant. P is equal to a constant. That means if the external force is acting on a system is 0, then the linear momentum remains constant. Now, we will see what is friction. What is meant by friction? So, what is friction? What is friction? Actually, it is a dissipative force. It's a dissipative force. So it is the force which opposes or which has a tendency to oppose the relative motion between the two bodies. When two bodies are in motion, or suppose if I am keeping an object on a table and I'm trying to move my object, so there is a tendency to oppose the relative motion. So that's called friction. And we can classify friction into static friction and dynamic friction. So all these things we know. So I'm quickly going through all these things. So finally we will solve the problems. At that time you will get much ideas. If any points, if I am missing here, you will get all the points which I'm at the time of solving the problems. So static friction. So what is static friction? So we can classify friction into two, static and dynamic friction. So static friction is the force of friction which comes into play between two surfaces in contact. Which comes into play between the two surfaces in contact. So suppose I am moving my object on a table. So at that time, what happens? There is some kind of friction which will arise. So that frictional force is called static friction. That static friction will increase as soon as I am applying the force. That static friction is also increase, and it will reach to a point that is called the limiting value or the limiting force of friction. So we can say that the static friction is a self-adjusting force. Static friction is a self-adjusting force, and which is given by Fs equal to mu s into n, where mu s is the coefficient of static friction and n is the normal reaction. So the force of friction that comes into play between two surfaces in contact before the actual motion starts. So that is called static friction. And this static friction is a self-adjusting force. It's a self-adjusting force. So it can adjust its value from 0 to a maximum value. What is that maximum value? So until it can reach a maximum, which is called the limiting value or the limiting force of friction, which is equal to mu s into n. So it can adjust its value from 0 to mu s into n. Up to here, it can adjust its value. Then what is dynamic friction? What is dynamic friction? What is dynamic friction? So this dynamic friction, when one body moves over the other, then the force of friction acting between two surfaces is called dynamic friction. So, or we can say that this friction plays at the time of its movement, and the dynamic friction Fd, which is equal to mu d into n, where mu d is the coefficient of dynamic friction and n is the normal reaction. But the point which you have to keep in mind is that the dynamic friction is not self-adjusting. It is not at all self-adjusting. It is not self-adjusting. Now, if you draw a graph between this applied force and force of friction, how it will looks like? How it will looks like? So let us draw a graph between applied force and force of friction. So in the x-axis, I am taking applied force, and in y-axis, I am taking force of friction. So as soon as I am increasing my applied force, what will happen? First, the static friction will increase. So at that time, the static friction comes into play. So how long it will increase, or how long it will go? When the force of friction, when the applied force is equal to a limiting value, we can say that it is limiting static friction or the limiting force of friction. At that time, what will happen? Then after that, the body is just start moves. So it will beyond that, the force of friction remains constant. So this value we can call it as kinetic friction. Kinetic friction. So this is called the static friction or the limiting static friction. Limiting static friction. Hello guys, is there any problem? You can Is it clear for you?
Yes,
Is my
sir.
sound and both video and audio are clear, right? Please just say or no. Tell me yes or no.
Yes, sir.
Yes, sir.
Okay, I can proceed, right?
Okay.
Yeah, fine. So this is the graph between the applied force and the force of friction. Now we will see what is the angle of friction and what is angle of repose. So suppose an object which lies on a table. So this is a surface, and I'm keeping an object on the surface. So this is the direction of the applied force. So what will be the direction of the what is the direction of the means the frictional force? Suppose this is Fs, static friction. We know that always this weight of the body is always acting downwards, right? So weight of the body is always acting downwards. So this is W, and the normal reaction, this is normal reaction N. Now angle of friction, actually the angle of friction is the angle which is the we know that the resultant of this static friction and the normal reaction. So this is the resultant of this, both are vectors. So suppose this is the resultant of normal reaction and static friction, then I can say that this is the angle of friction. Suppose I'm taking it as lambda. So lambda is the angle of friction. So it is the angle which the resultant of normal reaction and limiting friction. It is the angle which the resultant of normal reaction and this limiting friction. So it is represented by lambda. So from this figure tan lambda, I can find tan lambda. So if you consider this as a right angle triangle, then tan lambda is equal to Fs divided by normal reaction N. But Fs we know that it is mu s into N divided by N, which is equal to mu s. That means tan lambda is equal to mu s. Then what is the angle of repose? Angle of repose. It is angle of repose. Suppose you consider an object which is lying on an inclined plane. It is lying on an inclined plane. So I'm just considering an inclined plane which makes an angle theta with the horizontal. So this is an inclined plane, and consider an object on this inclined plane. So angle of repose means it is the angle in which this inclined plane makes with the horizontal. So the body is about to start. So if you we know that the weight of this body is always acting downwards, and if suppose this object is about to move towards the means it is about to move to the ground, or we can say that the static friction at that time, the static friction is in this direction, Fs. So this is angle theta, and the normal reaction is perpendicular to the surface of this body. So this is the normal reaction, and we know that any vector which makes an angle theta with the horizontal, we can resolve into two components. So this is weight which is equal to mg. So this is a vector. Here it makes an angle. Here also it makes an angle theta. From the geometry, you already know that if this is angle theta, then this is also angle theta. So we can resolve this this vector mg into two components, that is mg cos theta and other the non-perpendicular component is mg sin theta. So in the equilibrium condition, I can write, suppose this is in the entire system is in equilibrium, then I can write mg sin theta is equal to fs. Mg sin theta is equal to fs at the time of equilibrium. So we know that fs is equal to mu s into n, where n is the normal reaction. So this normal reaction from the figure at the time of equilibrium, this normal reaction n is equal to mg cos theta, because it is equal and opposite forces. So I can write this is equal to mu s into mg cos theta. Mg cos theta. So this becomes, from this I can write mu s is equal to tan theta. Sorry, yeah, this is fs is equal to mg sin theta. So from this I can write mu s is equal to tan theta. Before we know that what is mu s, it is equal to tan lambda. Now it is mu s is equal to tan theta. So we can write this theta is equal to lambda. That means angle of friction is equal to angle of repose. That is theta is equal to lambda. So the next one is rigid body, that we will discuss later. So we will solve some problems regarding on these things. So I think you already have the question paper. So yeah, just let us look at the first question. So what is first question? Otherwise I will copy and paste. Yeah. You please read the question. So this is the first question. Two forces of magnitude F have a resultant of the same magnitude F. The angle between the two forces is the angle between the two forces. How we can solve this problem? Here, two forces of magnitude F. How we can solve this problem? Suppose I am taking two forces F. Suppose this is say F1 and the next force is F2. So this is first force, say F1, and suppose I'm taking two forces as the adjacent sides of a parallelogram. Suppose anywhere in this plane I can take it as the adjacent side. Suppose the force is in this direction, I can bring this force and I can put it here. So this is say F2. Here the question it says that both are having the same magnitude. That means F. Then what is the angle between the two forces? What is the angle between the two forces? I want to find these two. In between these two forces. So we know that according to the parallelogram law of vector addition, if two vectors are lying on the adjacent sides of a parallelogram, then the resultant vector is given by its diagonal. So according to parallelogram law of vector addition, this will be the resultant. So the resultant is given by its because I can form this as a adjacent sides of a parallelogram. So the resultant force F is equal to, or the net force F is equal to, we know that it is F1 square plus F2 square plus 2F1 F2 cos theta. So which is equal to, here both F1 and F2 are having the same magnitude. So it becomes root of F square plus F square plus 2F square cos theta. So which is equal to 2F square plus F square 2F square plus 2F square cos theta. So I can take it outside. 2F square I can take it outside. So then it becomes 1 plus cos theta. So this becomes, what is 1 plus cos theta? 1 plus cos theta I can write 2 cos square theta by 2. From the trigonometry you have studied this one. So this becomes 2 F square into 2 cos square theta by 2. 2 cos square theta by 2. So this becomes 2F square into 2 cos square theta by 2. What it is? It is 4F square cos theta by 2. 4F square to F cos theta by 2. So F and F get cancelled. So this becomes cos theta means cos theta by 2 becomes 1 by 2. So that means theta by 2 is cos inverse 1 by 2, that is 60 degree. So which implies theta is equal to 120 degree. So which one is the correct answer? Option B. So option B is 120 degrees. So this is the correct one. Now let us look at the second question. I think it's you already you can see the window, right?
Yes, sir.
Yeah. So you look at the second one. And can you just answer this one? A bullet hits a block. This one. A bullet hits a block resting on a frictionless horizontal plane and gets embedded. What is conserved? Momentum and kinetic energy. Kinetic energy alone, none of the above. What type of collision is this one? Is it elastic collision or is it inelastic collision? So you please think about it. Is it an elastic or inelastic? If it is elastic, there is the conservation of both mechanical energy and momentum. If it is inelastic, then there will be only a momentum conservation only will be there. So we know that this bullet is which comes under rest, right? And a bullet hits a block resting on a frictionless horizontal plane and gets embedded. So here the conserved quantity, this is inelastic collision. So we can say that the momentum is conserved in this problem. So the answer is option A. Now let us look at the third question. I will copy this question. Yeah. So this is the third one. Can you solve this problem? It is very simple. You just read this question. A bomb of mass 9 kilogram explodes into two pieces of mass 3 kilogram and 6 kilogram. The velocity of 3 kilogram mass is 16 meter per second. The velocity of 6 kilogram mass is, what is the velocity of the 6 kilogram mass? We can solve this problem using the conservation of momentum. So first, a 9 kilogram body or 9 kilogram mass, it's a bomb. So this is having 9 kilogram and it explodes into two. So explodes into two pieces. First one is having 3 kilogram and second one is having, say, 6 kilogram. And the velocity of 3 kilogram mass has given, that is 16 meter per second. Then what is the velocity of the 6 kilogram? 6 kilogram mass. So I want to find out the velocity of this 6 kilogram mass. So according to the conservation of momentum, we know that it is the momentum before collision is equal to the momentum after collision. So m1u1 is equal to m1u1 plus m2u2 is equal to m1v1 plus m2v2. So here, what is the momentum before collision, or what is the momentum before explosion? What is the momentum before explosion? It is 0 because it was under rest actually. So the momentum before collision, before explosion, it was 0. It is equal to 0. Now the momentum after explosion, which is equal to, suppose m1v1. This here the 3 kilogram mass. This 3 kilogram mass is having 16 meter per second. So what is its momentum? 3 into 16. So 3 into 16 plus, what is the momentum of this one? We don't know what is its momentum because we don't know what is the velocity. So what we have to find out? We have to find out the velocity of this 6 kilogram body. So the 6 kilogram, I'm taking the velocity of 6 kilogram as v, so 6v. So I can write the momentum before explosion is equal to momentum after explosion. So from this I can write 6v is equal to 3 into 16, it is 48. So that means v is equal to 48 divided by 6. 48 divided by 6 means 8 meter per second, right? So the velocity of 6 kilogram body or 6 kilogram object is having the velocity 8 meter per second. So it is very simple from the conservation of the law, conservation of the momentum, linear momentum. So option is B. So option B is the correct answer. Now let us look at the fourth question. So just a minute. Yeah. Oh, figure has not come. And I will replace. Yeah. Okay. So this is the fourth one. You just read this question. a block of mass 2 kilogram is placed on the floor. The coefficient of static friction is 0.4. A force of 2.5 Newton is applied on the block as shown. So what we have to find out here? What we have, question is incomplete. Yeah, we have to find out the force of friction between the block and the floor. That question is incomplete actually. Okay. Yeah. You please read this question. Here, a block of mass 2 kilogram is placed on the floor. So this is having this is 2 kilogram body which is lying on a floor. The coefficient of static friction is given, that is mu s is equal to 0.4. A force of 2.5 Newton. This is applied force, so that is also given. F is equal to 2.5 Newton, which is applied on the block. Now, what is the force of friction between the block and the floor? So as soon as I am applying a force, there will be a force of friction in this direction. Suppose this is Fs. Then what is my Fs? What is the force of friction, or what is the force of static friction? What is the limiting force of that friction? So we know that the limiting force of friction Fs is equal to mu s into r, or mu s into n, whatever it may be. In some texts they are using capital N, or in some texts they are using capital R. So this is equal to mu s. The normal reaction is suppose this is the normal reaction. So under equilibrium, this is the weight of the body is acting downwards. W is equal to mg. So under equilibrium, mu s is equal to mg. Sorry, R is equal to mg. So the static friction, the limiting force of the static friction is equal to mu s into mg. Okay. So now mu s has given. Mu s is equal to 0.4. And mass of the body is also given, that is 2 kilogram. And g, acceleration due to gravity, it is 9.8. So if you multiply this one, finally you will get the answer as 7.84 Newton. 7.84 Newton. So is there any option 7.84? There is no answer as 7.84. So you will put none of the above, right? You will put none of the above, but it is not the correct answer. So here the applied force is 2.5 Newton. They are asking what is the force of the friction between the block and the floor. It means they are asking the static friction. So I told you that the static friction is self-adjusting force. It can as I am applying the force, the static friction is also will increase. So it will increase from 0 to 7.84 Newton. So this is the maximum value. Then it will, if it overcome this maximum value, then the body is just it's about to start its motion. The body is about to start the motion. So here the applied force is F is equal to 2.5 Newton. So that is less than the limiting frictional force, because we got the limiting frictional force as 7.84 Newton. So it is less than the applied force is less than the limiting frictional force. That means the block does not move. Because when we overcome 7.84 only, it will start to move. So I can say that the frictional force between the block and the floor is again what it will be 2.5 Newton. Because if I am applying 1 Newton, then the static friction will become 1 Newton. 2 Newton, it will become 2 Newton. Up to it will go up to 7.84. After that only it will start to move. So we can say that the force of friction, since the force of friction or static friction is a self-adjusting force, the frictional force between the block and the floor is 2.5 Newton itself. So the correct answer is 2.5 Newton. Because there is a chance of committing mistakes, because we will calculate this Fs and we will get 7.84 as the answer. So there won't be any 7.84. So there is one option, none of the above. So we will put none of the above. If we put like that, we will get the negative mark. Now let us look at the fifth question. So this is the fourth one. Now what is the fifth one? Let us look at the fifth one. Yeah. So a bird is sitting in a large closed cage which is placed on a spring balance. It records a weight of 25 Newton. The mass of the bird has given, that is 0.5 kilogram, which flies upward in the cage with an acceleration of 2 meters per second square. The spring balance will now record a weight of. Just read this question. Here the bird is sitting in a large closed cage. And this cage is means it is hanged by a spring balance. And the spring balance records a weight of 25 Newton. So when the bird flies upward in the cage with an acceleration of 2 meters per second square, then what is the spring balance means? What is the value of this spring balance? How it can, what is the measurement it shows? So we know that the bird sits, when the bird sits or flies inside the cage, the total weight will not change in any case. Whether the bird sits or flies inside the cage, the total weight will not change in any case. So the only additional force comes. The only additional force means the only additional force which will come into play is the force on the base of the cage. So what is that force? We know that from the Newton's second law, it is F is equal to ma. So what is the additional force on the cage? That is mass into acceleration. So initially it records a weight of 25 Newton. When it flies inside a cage means whether a bird which sits or flies inside the cage, the total weight will not change in any case. The only additional force is on the base. That is force that is due to this mass into acceleration. The bird is having 0.5 kilogram mass, and it flies with an acceleration of 2 meters per second square. So the total weight will be this 25 Newton and plus this force. So this is equal to 0.5 into 2. So which is equal to 1 Newton. So the total weight will be 25 plus 1, that is 26 Newton. So the option C is the correct answer. Now let us look at the sixth one. I will just copy this one. Yeah. So sixth question. I think you can see this. See the question, right? If somebody, yes, please, somebody says, unmute
Yes,
your
sir.
mic. Okay. Because in a virtual mode of this class, actually it feels boring. So if in between, if anyone say yes or no, then I can proceed accordingly. So you just read this question. Here, a lighter body of mass m1 and a heavier body having mass m2. So the first body means lighter body is moving with a velocity v1 and heavier body is moving with a velocity v2, and which is both are having the same kinetic energy. Then which option is correct one? The momentum of the second body is less than the momentum of the first body. Both bodies are having the same momentum. So m2 v1 is equal to m1 v2. So which one is the correct option? Any idea? Here it has given that both bodies are having same kinetic energy. So kinetic energy of the first body, suppose it is K1. Kinetic energy of the first body is K1. So we know that kinetic energy is half mv square. Half mv square. So here I can write it as half m1 v1 square, because first body is having mass m1 and second body is having mass m2. So we know that the kinetic energy has another expression also, which is equal to p square by 2m. Actually, this p square by 2m is obtained from this equation only. If you multiply numerator and denominator by m1, if you multiply numerator and denominator by m1, then you will get m1 v1 whole square divided by 2m1. So this is the momentum of the first body. So you can write p square. Here you can write p square. So p square by 2m, or m1 v1 square by 2m1. So this is the kinetic energy of the lighter body. Now what is the kinetic energy of the heavier body? So suppose K2 is the kinetic energy of the heavier body. So K2 becomes m2 v2 whole square divided by 2m2. So in the question it has given that both are having the same kinetic energy. That means suppose this is equation 1 and this is equation 2. So equation 1 is equal to equation 2 because both are having the same kinetic energy. That is K1 is equal to K2. So that is m1 v1 whole square divided by 2m1, which is equal to m2 v2 whole square divided by 2m2. So from this expression, I can write, just divide this one. From this equation, I can write m1 v1 whole square divided by m2 v2 whole square, which is equal to 2m1 by 2m2. 2 and 2 get cancelled. So this becomes m1 v1 divided by m2 v2, which is equal to root of m1 divided by m2. So from this equation, you can conclude which option is correct answer. Because it has given that the mass of m2 is greater than m1, because m2 is the mass of the heavier body. So since m2 is greater than m1, just a minute. Just a minute. So since m2 is greater than m1, I can write m2 greater than m1. I can write, see the denominator. So I can write m2 v2 is greater than m1 v1. So this is the correct answer, because it have we have reached this expression m1 v1 m1 v1 is equal to okay. Now let us look at the, so this is the correct answer. Now let us look at the seventh one. What is seventh one? I will just copy that question. Yeah, it is very simple. Yeah, choose the correct statement from the following. Weightlessness of an astronaut moving in a satellite is a situation of 0g, no gravity, zero gravity, means no gravity, zero mass, free fall. Choose the correct statement from the following. Weightlessness of an astronaut moving in a satellite means it is a situation of zero acceleration due to gravity. So it is 0g. Option is answer is A. Means the astronaut will be having zero acceleration due to gravity. So that is simple one. So next question, I think that also you can solve by yourself. It is from the conservation of momentum. I will just copy that one. Yeah, eighth one. You please try to solve by yourself. A particle of mass m moving with velocity v strikes a stationary particle of mass 2m and sticks to it. The speed of the system will be. Here also what you have to do is you just take the conservation of momentum, and finally you will get the answer as, means the first body, say, is moving with a velocity v. This is having mass m and strikes a stationary particle. So second body is under stationary. So this particle is having mass 2m. Then after collision, both the bodies are sticks together and moving with a velocity that we don't know, So that velocity we have to calculate. So after that, these two object will sticks together, means it will be having mass 3m. And suppose this is moving with a velocity v dash. So that velocity we have to calculate. So according to the conservation of momentum, I can write mv, the momentum before collision. So initially the 2m was under rest. So its momentum is 0. So mv is equal to 3m into v dash. So m and m get cancelled. So v dash is equal to v by 3. V dash is equal to v by 3. So that is option C is the correct answer. Now let us look at the 9th one. It's very important. Read this question. A weightless string is suspended on a frictionless pulley of mass 6 kilogram, and which is suspended at one end, and mass of 6 kilogram is suspended on the other end of the string. The tension in the string will be the tension in the string. So you just look at and read this question. A weightless string is suspended on a frictionless pulley of mass 6 kilogram. Here this body is having mass 6 kilogram, and this body is having 10 kilogram. So if you get this kind of question, what you should do? First, you have to draw this, means the free body diagram. Free body diagram means you just find what is the direction, what is the direction of the force, what is the direction of the tension. But okay, so let us look at this one. So here the mass of this body is 10 kilogram, right? We have to calculate what is the tension experienced in this string. We have to calculate what is the tension experienced in the string. Okay. So if you get a problem like this, what you should do? You first you just try to put locate the positions and the direction. So, just a minute. Yeah. So here the weight of this body is acting in this direction. So the tension will be in this direction. But in this part, here the body is having 10 kilogram mass. Here the body is having 6 kilogram mass. So we know that which side mass is higher, the pulley will rotate in that direction. So the pulley will move in this direction. So here the weight is downwards, but tension, we know that it will be away from this body. The tension will be in this direction. But the entire system is moving in this direction, means acceleration of the system is towards this direction. So this is the first section, or this is the second section. Okay, this is the first section and this one is the second section. So we have to find the tension experienced in the string T. And we don't know what is the acceleration of the system. We don't know what is the acceleration, because the system is moving in this direction, because the mass of the second one, means 10 kilogram mass, is higher than that of the First case 6 kilogram. So obviously it will move in this direction. So at that time, what we have to do is we have to form an equation of motion for the first case and for the second case, and solve that equation. You will get the acceleration. Then you can substitute the value of acceleration in any one of the equation. So finally you will get the tension. So let us look at the first part, 6 kilogram part. So what is the equation of motion we can write? The first case, this is tension is in the upward direction, and since the tension experienced will be higher than that of the weight experienced for this mass, because that system is moving in this direction. So I can write tension will be higher. So T minus this is tension experienced. So this is the weight in the downwards. This is weight downwards. So T minus mg means 6g is equal to what is the force experience for this part? It is m into a. But I don't know what is acceleration of the system. But right now I can write m into a. Okay. Because the force experienced for this part is mass into acceleration. As the system is moving in the right direction, I can write the equation of motion as T minus 6g is equal to ma. So this is the first equation. And for the second part, here the system is moving downwards in this direction. So yeah, so I can write 10g. This will be higher than that of the tension experienced in this part. So 10g minus T is equal to, here the mass of the body is 6 kilograms. So I can write 6 into a. But here I can write 10 into a. So this is equation 2. Now solve these two equations, you will get what is the acceleration experienced for this system. So what you have to do, just add these two equations. You add equation 1 and equation 2. So on adding equation 1 and 2, you will get just a minute. Yeah, on adding equation 1 and 2, you will get T and T get cancelled. So 10g minus 6g means 4g, which is equal to 10 plus 6a, that is 16a. So acceleration of the system is equal to 1 by 4g. 1 by means 4 divided by 16g, that is 1 by 4g. So this is the acceleration. Now substitute the value of this acceleration in any of the equation. Let us take equation 1. Okay, so substitute the value of the acceleration in equation 1. You will get T minus 6g is equal to, it is 6a, that is 6 into 1 by 4g. So from this expression, T is equal to (6g) plus 6 by 4g means 6 by 3 by 2. So 3 by 2g. So 6g plus 3 by 2g is around 15 divided by 2g. If you substitute the value of g 9.8 and solve, you will get the answer as 73. So this is 73.5 Newton. Okay. Any doubt in this question? Please tell me yes or no. Please somebody unmute and just say yes or no.
Sir.
Yeah.
Sir, how this tension T is same on both sides since the weight is different. So how the tension be same?
Because here we can take it as the entire system, and tension will be same. Tension will be same.
Oh,
Okay, because in the question it says that it is a friction, means it is a massless pulley. So since it is a massless pulley, whatever be the T1 or T2, means it will adjust its value. In between there is no other masses comes, then in between there is no other masses comes, right? Here
yes.
the pulley's mass is negligibly small. So if in between, if anything comes in between this, then we can say that the tension experienced for each part will be different. Otherwise, we can say that it will means whatever be the means this here the pulley's mass is, since the pulley's mass is negligibly small, then it is equally distributed. So the tension will be equally distributed whole this part. So it will be same. Okay.
Oh, okay, sir. Okay, sir. Okay.
Okay. Now let us look at the 10th question. If any interruption comes in between, you please inform me, okay? Yeah. Here a force of 5 Newton acts on a body of weight 9.8 Newton. What is the acceleration produced in meter per second square? What is the acceleration produced in meter per second square? Can you solve by yourself? Simple one. Here a force of 5 Newton acts on a body of weight 9.8 Newton. So the first body. So I'm acting a force on this first body. So this is the force acting on the body, which is equal to, it has given that is 5 Newton. And the weight of the body, suppose the weight of the body, this is a direction mg. So that's also given. The weight on the body is 9.8 Newton. So what is the acceleration produced in meter per second? So suppose it is moving in this direction, then what is the acceleration produced? So we know according to Newton's law, F is equal to mass into acceleration. Mass into acceleration. But we don't know what is mass and we don't know what is acceleration. The only thing which I know is 5 Newton. So I'm applying with a force of 5 Newton. So for that, we have to calculate what is the mass of this body. So from the value of its weight, we can calculate what is the mass of the body. So mg is equal to, it has given 9.8 Newton. So mass is equal to 9.8 divided by g. The value of g is 9.8 meter per second square. So it is around 1 kilogram, right? So mass of the body is 1 kilogram. Now you can find out what is the acceleration produced. So force F has given. So force F has given. F is equal to ma. F is equal to m into a. So this becomes 5 Newton, which is equal to mass into acceleration. So mass we already got it, 1 kilogram. So 1 into a, that is a is equal to 5 meter per second square. So this is the correct answer. So option acceleration, yeah, option B. Now let us look at the 11th one. Okay, within 15 minutes I will leave you, okay? Because in the beginning we lost around 15 to 20 minutes. So by 9:45 I can stop. Fine? Yeah. The mass of a lift is 500 kilogram. When it ascends with an acceleration of 2 meters per second square, the tension in the cable will be. The tension in the cable. So suppose this is a lift. The mass of this lift is 500 kilogram. So this is moving upward direction. So when it is ascends with an acceleration of 2 meters per second square, what is the tension experienced in the string? So we know that its weight is acting downwards. So this is mg. So, so this is the free body diagram. So we know that the acceleration of, because when it ascends upward direction, this acceleration, the direction of the acceleration in the upward direction. So this is the free body diagram. Now from this you can establish an equation. So T minus mg, T minus mg is equal to mass into acceleration, that is ma. So T minus mg, from this one you will get T is equal to mg plus ma, that is m into g plus a. So m is given, that is 500 kilogram. G is you can take approximately 10 meters per second square. Acceleration is also given 2. Now it is 10 plus 2, it is 12. 12 into 5, it is 60. So 60,000. Sorry, 6,000. Yeah. So it is around 6,000 Newton. Yeah, option A. So this one is the correct answer. Now let us look at the, or you can without doing this free, means without drawing this free body diagram itself, you can find out, because you have studied in a lift which is moving upward direction, what is the net weight acting on this, acting on a lift which is moving in upward direction. What is the apparent weight of a lift which is moving in the downward direction? That you already know. From that you can calculate this one. When a lift which is or the apparent weight of a lift which, when it is going downward, it is m into g minus a. When it is moving in the upward direction, it is m into g plus a. In that sense also you can find out this answer without drawing this diagram, or without forming the equation of motion. Without forming the free body diagram or anything like this, you can find out the answer. Now let us look at the 12th one. So time is running. 12th one. A particle of mass m is projected with a velocity u at an angle theta with the horizontal during the period when the particle descends from high. I will leave you by 9:45. Okay. So please be sorry for the extra time. So I will wind up within 10 minutes. So a particle of mass m is projected with a velocity u at an angle theta with horizontal during the period when the particle descends from the highest point to the position where its velocity vector makes an angle theta by 2 with the horizontal. Work done by the force of gravity. You have to find out the work done. you have to calculate the work done by the force of gravity. So during the projectile motion, we know that it is a kind of projectile motion. So m projected with a velocity u at an angle theta. So suppose if we draw this one, this is the surface, and suppose I am drawing an object with suppose this is the initial velocity u, and which suppose this makes an angle theta with the horizontal. And in the question it says that during the period when the particle descends from highest point, when it descends from highest point to point where its velocity vector makes an angle theta by 2 with the horizontal. So during its descent, it makes an angle theta by 2 with the horizontal. That means this is the velocity v. So with the horizontal, it makes an angle theta by 2. So this is theta by 2. Okay, so it is theta by 2. In the question it says like that. Now, what is the work done by the force of gravity? So during the projectile motion, we know that we already constant. So that means that the velocity, the horizontal component of the velocity does not change during a projectile motion. So if u is the velocity, initial velocity, then what is the horizontal component of the velocity? It is u cos theta. Here we have to find out the work done by the force of gravity. So we know that from the work energy theorem, work energy theorem, what is work energy theorem? The net work done W is equal to change in kinetic energy. Change in kinetic energy. So this is equal to suppose v is the final velocity, then I can write half mv square minus half mu square. If u is the initial velocity, v is the final velocity, then the change in kinetic energy becomes half mv square minus half mu square. So here we don't know what is v. So we have to now we are going to deal with the horizontal component of the velocity. Since the horizontal component of the velocity does not change during the projectile motion, we are dealing with the horizontal component of the velocity. But I don't know what is my final velocity. So final velocity v, because if you look at the answers in the option, all the options are in terms of initial velocity, right? It is half mu square tan theta by 2 minus half mu square tan square theta by 2, like that. So all the options are in terms of initial velocity u. So I should represent my final velocity in terms of u, initial velocity. So how can I connect my final velocity with the initial velocity? So one thing we know that the horizontal component during its projectile motion, the horizontal component of its velocity is constant. So horizontal component of the velocity is constant. That means u cos theta. Initial velocity was u. So the horizontal component of initial velocity is u cos theta, which is equal to the final velocity is v. So we know that the horizontal component of the velocity is v cos theta by 2, because in the question it says that during its descent, it makes an angle theta by 2 with the horizontal. So the horizontal component of the final velocity is v cos theta by 2. Now I have to express my final velocity in terms of initial velocity. That is v is equal to u cos theta divided by cos theta by 2. Cos theta by 2. So this is the final velocity. But we have to calculate what is the change in kinetic energy, or in the question it asks what is the work done by the force of gravity. What is the work done by the force of gravity? So according to work energy theorem, we know that the net work done on a body, if we apply a net force of F on a body, then the net work done on the body is the change in kinetic energy. Change in kinetic energy. But we have to calculate change in kinetic energy, but I don't know what is my final velocity v, because in the option it says it has given in terms of initial velocity u. So for that I have to express my final velocity in terms of initial velocity. Now you substitute the value of v in equation. Suppose this is equation 1. Substitute the value of equation. Substitute the value of the value of v in equation 1. So w becomes half m into what is v? It is half mv square. So it is half m into u square cos square theta divided by cos square theta by 2 minus half mu square, that is minus half into m into u square cos square theta. So which is equal to half mu square cos square theta is common, so I'm taking it outside. So half mu square cos square theta into 1 by cos square theta by 2, it is sec square theta by 2 minus 1. So which is equal to half mu square cos square theta into what is sec square theta by 2 minus 1? From trigonometry, you have studied that sec square theta minus 2. So sorry, sec square theta minus tan square theta is equal to 1. So here you can write sec square theta by 2 minus 1 is equal to tan square theta by 2. So this is the correct answer. So it's option C is the correct one. So what we shall do? Let us. We have evening class by 7 o'clock. I think that time we will. You try to solve the rest of the question. Okay. I will give you the answers, and if I can go for some more minutes, I can complete. Otherwise, what we will do? We will solve after by evening session, or we can proceed now itself. What you people are saying? Please tell me. Somebody please unmute your mic and tell me. If we can go now, we can proceed. Otherwise, we will solve the rest of the question in the afternoon session. Hello, guys. Can you hear me?
Yes, sir.
Okay, so I think you people are tired. Anyway, we will solve this question in afternoon session. Okay, by 7 o'clock. Some more question I have to solve. Okay, let's wind up now.
Okay, sir.
Okay then. Okay, bye. So we will see we will see by evening. Okay. I will give you this notes by PDF. I will send you. Okay then. Bye. Thank you very much. So we will see in the afternoon by 7 o'clock. Okay.
Thank you, sir.
Okay. Thank you very much. Bye.